We'll be continuing chapter 8.3, yeah, which is on wedges. Yeah, wedges. Now, the frictional forces on flat belts is not in the syllabus. So we'll be only looking at wedges, yeah. So I will actually guide you in how to determine the forces on the wedge itself. Okay, let's look at the application. Where is wedge applied? Yeah, I hope I didn't make you hungry, yeah, talking about wedges, huh? So yummy, isn't it, huh? Thinking about the McDonald's potato wedges with some cheesy topping. Yeah, hope you had breakfast before coming for my lectures. Yeah, okay. Wedge are used to adjust the elevation and provide stability for heavy object, such things like large steel pipes, yeah, so that it doesn't come off, your house door stopper. So whatever that is in the shape of like triangle like this, it's known as wedges, yeah. Okay. Sometimes you park your car uphill, yeah, you always want to put something to stop the car from rolling down. So this is where wedges is actually applied. It's like self-locking, yeah, self-locking kind of tool. Yeah, we're not going to look at flat belt, so we're going to continue. So analysis of wedges itself, it's a simple machine which is a small force P used to lift the large weight. So if I were to push this P inside, this object will actually move up. Okay, that's what they're trying to say, to lift a large weight. Yeah, so not only to actually stop the object from moving, but also to lift up, give a slight lift. So yeah, okay. To determine the force pushed required to push the wedge in and out. So it is necessary to draw the free body diagram of the wedge. So I'm going to guide you step by step in how we want to draw the free body diagram of this wedge itself. Remember, if you have a push, then the friction will oppose. Friction always opposes the direction. Yeah. So the most important thing is whether it's a push or it's a pull. So if it's a pull, if you pull out, where will the friction be? The same thing, but it'll be pointing in the opposite side. So that's how the drawing is being done. Okay. Later, I will show you the combination drawing for both the wedge and the object. Yeah. Okay, friction force always in the direction or opposite. This is what I was just trying to say. Yeah, the friction force is along the contacting surface. The normal force perpendicular. So you have the normal force, which is always 90 degrees to the surface. Okay, so now remember, if okay, I should get something which is actually combined. Then you can see the whole thing. Okay, let's keep this. This is a good thing. Next, FBD of the object. Okay, it's easier to actually look at the FBD if they are combined this way. Okay, look at this. Watch this carefully. You have a pull, so that is the first thing. That is the most important thing that you need to look at it. So in this case, it's not a pull, it's a push. You have a push inside. So when you push it inside, what happens? This whole block is actually moving up. It's moving up. Okay, got it or not? Okay, so now I'm going to label this. Because of that, you have a friction opposing. This F2 and this F2 are partners. Yeah, they are same. So whatever value that you have calculated for this F2 here and the N2 here, they are partners. Okay, they are same value. Okay, that's why it's being labeled same. F1, N1 is different from F2, N2. F3, N3 is also different because they are different surfaces. Okay, so only these two are partners. They are partners, but they are in opposite side. Okay, now if you look at this box again, yeah, observe this box again. So because you have a push, the friction is actually opposing. Can you see that? Yeah, correct or not? Yeah, because you have a push and this thing is going up. Because this goes up, this friction with this wall here, there's a wall here, yeah, the friction with the wall will actually be down. This normal force, very easy. You just have to blindly draw 90 degrees to the surface. That's it, finished story. Okay, now because this floor went on the left, this floor will go on the right. So they are partners. Okay, so that is how the free body diagram is actually drawn. Okay, so it all depends on the movement itself. If this thing is being pulled, this block is going to drop. If the block is going to drop, the friction of the block will be up. You understand or not? So how the wedges will, how the wedge movement will, because it's going P out, the friction is this side. You understand or not? Yeah. Okay, I'll show you an example for you to make you understand even better. So let's just move directly to the example. We are done with the lecture note. Let's just look at the example. Okay, once again, let me just give emphasize here. You have a push inside. Because of the push, you have the friction opposing, correct? Okay, and if you see, this friction and this friction is the same value, but they are in the opposite side. Okay, they are in the opposite side. Okay, if you join them together, if you join this together, you see that they cancel off each other. Okay, because you pushed, this block actually moved up. Sorry, if the thing moved up, then the friction will be down. You got it or not? Yeah. Okay, that's how it is. So let's solve a question here. So the most important movement is to see is the wedge itself. The wedge is the key movement. Yeah. So let's look at this question. The uniform stone has a mass of 500 kilogram and is held in a horizontal position using the wedge at B. If the coefficient of static friction is mu as 0.3 with the surface of contact, determine the minimum force needed to remove the wedge. Okay, the most important thing what you should do is actually, number one is to look to the diagram that's given. Number two is to draw the wedge. Yeah, forget about drawing this first. Forget about this first. Number two, step two is always drawing the wedge first. Okay, so you take out the wedge. Like in this case, you have drawn the wedge, one following the P. So once you get the following the P, then you have the partners, which is in this case the NB and NC, and then you have your N. Okay, why is it 0.3 NC? Because question has given that the friction is actually, and this value is actually 0.3. That's why it's all written 0.3, because they have said that the surface and the surface contact is 0.3. That's why it's 0.3. Yeah. Okay, so once this is done, what do? You draw the partner here. Yeah, you draw the partner, which is 0.3 NB. This is pointing downward, this will be pointing upward. This will be pointing downward here, this will be pointing upward. So it's like partner, yeah, one gang like that, yeah. Okay, so once that's done, of course, wait. No, it's always pointing downward. Okay, so now you need to imagine. If the wedge is actually pulled out, what happens to the friction here? Okay, it means the whole thing is actually slightly moving to moving to the right. That's the reason why the friction is actually on the left. So this is the reason why I told you to actually draw the wedge first. Draw the wedge first. Yeah, step one. Step two, only draw the other object, yeah, whatever that's associated with the wedge, because otherwise this is unknown. You don't know which direction, you don't know a lot of things, you even don't know this direction. Yeah, that's why it's important to draw the wedge first. Yeah, this is very important. So once you've drawn the free body diagram, next is to solve for your for the unknowns. Solving the unknowns can come from any side. Yeah, you can solve from this side or this side. You just look at which is least complicated. Sometimes the wedge can be very complicated because don't know, so many things, don't know. Okay, but in this case, you see, look at this side. Yeah, this one you know a lot of things here, because you know why? A lot of hint has been given. Yeah, that's the reason why you see, if you see this textbook, they're actually solving for the block. Yeah, they're solving for the block. Okay, let's look at the working here. So what we have here, I'm taking moment at A. Take moment at A, you can calculate for your NB, right? Okay, 4905 pointing here. Okay, the value multiplied with 0.5. Okay, why is it negative? Clockwise. And then we have the NB. Okay, this NB cos 7. Okay, making it upright, this filler, making it upright. NB cos 7, the distance is actually 1 meter. Yeah, the distance is 1 meter. And then we have the sine. Yeah, just now was cos, now we have the sine. Okay, sorry, we have the cos just now, but if the sine, this thing will be pointing at the straight line with this same line, so 0. Yeah, okay, NB, yeah, NB, the partner for this, NB cos 70, the distance is 0, so it's equivalent as not to write it. Yeah, okay, observe that. Okay, so we don't have to write the partner. So next we will be moving on to the other member, which is the 0.3. Okay, the 0.3, if you make it flat this way, then it's going to run again on point A, correct or not? Yeah, so the only thing that you can make is make it upright. See the angle, it's like a triangle here, right? Like this. Can you see that? Yeah, so if you make it flat, then it'll be running on this A, so you have to make it upright. That's the reason why it is 0.3 NB sine 7. Okay, and when it's upright here, when it's upright, the distance is 1 meter. So you get your NB. Once you have solved for your NB, yeah, there are a lot of things that you can solve. You can use your wedge itself, because you got your NB, you got your NB. You can use your wedge to find the NC. Okay, you can use the Fy equals to 0. Okay, this is a bit straightforward. Then once you got your NB, NC, you can actually find for the P value. Okay, let's look at the working for P value. Okay, use your Fx equals to 0, so you can find the P value. Okay, anyway, I want you to redo all this and then send it back to me. Yeah, since P is positive, indeed the wedge must be pulled out. If P was 0, the wedge would remain in its place. It's self-locking. So in this case, it is a positive value, which means the P will be pulled out. Yeah, must be pulled out. Okay, so that is the explanation for this whole wedge. Okay, so with that, I'm actually ending my lecture of part 8.3. Okay, so the syllabus actually stops up to wedge. There will be no any other chapters asked. Yeah, 8.4 and so forth is not coming out in your syllabus, so you don't have to, you can have a look at it, but you don't have to study it for the exam. Okay, with that, thank you.